Me to talk about the NIMS Openscapes training program and NIMS Open Science. A little bit of background about me before I get started. I am the co-PI of the NIMS Openscapes program, which I'm going to be talking about. I'm also lead of another group called NIMS Open Science, which I'll talk about a little at the very end. I'm a research scientist at the Northwest Fisheries Science Center. However, starting in the next fiscal year, I'll be working with the NOAA Fisheries Office of Science and Technology, leading up the NIMS Open Science efforts in a variety of different ways. I'm also currently the new NIMS rep on the PAR working group. However, for the purpose of this talk, I'm going to be speaking as a representative for the NIMS science and data teams. This includes, obviously, research science at our 6 science centers, but also data science teams that are working on reports, analyses that inform NIMS policy and regulations. The latter teams might be found at our regional offices. So that's a little background about me and what kind of the perspective I'm bringing to this talk. The first part of this talk is going to be an overview of the last 3 years of the Openscapes Champions program. It's this training program in open science and reproducible workflows. And then in the last half, I'll give you an update about what's to come next. So let's start off with definition. What is open science? Here's a slide from a presentation from NASA about the 2023 Year of Open Science, which is happening right now and which NOAA is also participating in. If you look at this definition, it's really focusing on the bottom part of these tenets of open science. Ease of access of knowledge for all, open access to research results. So it's a very important aspect of open science. But what I'm going to focus on today is not on that part. I'm going to focus about something at the top here, this part at the top that about reproducibility of results. And this has really motivated 30 years of work within the science community surrounding adoption of open science and reproducible workflows. So there's something called the reproducibility crisis in science, and this refers to the recognition within the science community that results of many scientific studies are difficult or impossible to reproduce. And that this lack of reproducibility has to do with the way that science has traditionally been done. It's nothing to do with intentional or unintentional deception. It is about this lack of reproducibility arises because of a combination of issues. First off, there's all these cultural norms about not sharing data and not sharing your work until it's final and you publish it. 2, there's a big bias against publication of boring results. We often call these null results, but it's all kinds of boring results. It's bias against that. Thirdly, there's just the very organic and very human nature of the scientific process. And there's a difficulty of replicating that very organic process. And 5th, there's resistance to adopting new methods of working and habits of working that kind of deal with number 3 and number 4. So this crisis is something that scientists are very aware of. They're very cognizant of it. It does directly affect the way that we do science, the way we publish and do research. If you're within a medical field or psychology, it's going to affect you more. They've implemented norms to guard against this bias against publication of boring results. Within fisheries, we run into this, I would say most commonly, when we're required to publish data with our papers. So that's really been for a number of years that many journals, certainly the high-profile ones, require that the data be published with the paper or we put it in a public archive. If you write a grant proposal, it's similar. You have a section on how you make your data public. But, one of the debates has been, okay, great, So now we're starting to make our data public. Is that enough? If you have the data and you have the written methods, is that enough? Can you replicate the results? So that's been a debate, but was hard to study before. But in the last few years, now that we have more and more data provided with published papers and the published methods in those papers, researchers have been able to do meta-studies where they try to replicate people's results. And in the last about 5 years, we're starting to see papers on this. I was easily able to find 4 or 5 recent ones that have came out in the last 3 years. And this is a case, they have the raw data, they have the written methods, and all of these papers are showing across the board low replication rates. So low as in like under 25%. One recent study also looked at papers associated with regulatory decisions, and this was in hydrology, found similarly low replication rates. So what's going on here? So as I said, it's fundamentally the way that we do science makes it that we end up with something that's hard to replicate. So we have their data coming in. So we know what the data are, but there are just all these things in this gray box that are decisions that are made along the way, things that influenced what you did. And you can write up your methods, but there's always going to be things that are not in there. And so what happens when you have this, I think especially when we're thinking about like our big government reports, that has a especially big gray box here. And we end up, through all this meat grinder here, ending up with something that is fundamentally unreproducible. Now, right afterwards, sure, you can reproduce it. You got the whole team there. They can talk. They can, if they're not able to reproduce like a figure, they can talk it over and kind of recall what happened. But, a year later, 5 years later, what if you have somebody else who wasn't on the team, tries to reproduce that result? That's hard. So that's the bad news. But we have good news. The good news is we know how to create reproducible science workflows, and the tools have gotten much, much better and easier to use. Been lots of work on this across science. And the first part here is the data. We need to have data that are durable, that other people can understand. Years later, people who didn't collect the data can understand them. So that's the really important work that data governance groups are doing. I'm concerned with the next part, with the pipeline. You get that data, how do you create analysis pipelines that can be reproduced? And again, people have been working on these how to do a science pipeline or workflow that's reproducible. Lots of work on that. It's gotten a lot easier. The tools have gotten much, much better. And what's really cool is that, for individual teams who learn this, it's transformational for them. This is a video that you can watch from the link if you're within NOAA. It's a NOAA internal link of a team that went through the training program I'm going to discuss. And I think they went through it twice. So it was over like 6 months. They devoted 2 hours a week. So it's not a huge amount of time, but talking about their current workflows, figuring out where are the problems, learning new skills, and then committing to changing the way they work. Instead of working solo, they work together. They talk about things rather than spending 3 hours on tedious manual tasks that are repeated hundreds of times across many members of the team. One person spends 20 hours to code up that task so that it can now be done in 10 seconds. And if you listen to that video, you can hear in their voices, their excitement, their enthusiasm, And really, when teams are relieved of these tedious tasks that they know that just could be automated, and they don't have to do them anymore, it frees them up to do much more interesting things and really invigorates them. So from their perspective, it's like this. Beforehand, they're, the swamps in the reports in the swamp, the reports going through that meat grinder there, and they are too. And then afterwards, yay, better teamwork, new skills, better workflows, and that big report is getting out of the unreproducible morass. So that's where individual teams are. But me, I'm still here because as someone who thinks about how to train teams and is concerned about organizational change, like cultural change across a whole organization, I'm still in the swamp because I'm thinking, wow, okay, that's great. Do that for one team, but how do we make this go viral? Because one team at a time, that's slow. So why should we do that? I mean, why should we want to make this go viral? Why not just focus on individual teams? Well, there's a lot of dark clouds on the horizon, and the really big one is the cascading effects of climate change. And with that, there are going to be huge effects on all of our science. Just one example is that the models we have developed and trained, they've been developed and trained on data from an ocean and freshwater aquatic systems that look very different than the ones we're going to have in the coming years. Species are appearing where they've never appeared before, and the basic environmental drivers of systems are changing, both in the level, but also, importantly, in the variability of these systems. That means we're going to have a lot of extra work to change our models. Yeah, doable, yes. A lot of work, yes. On the good side, we've got all this great new data and new data streams. But, wow, that means we got a lot of new data and data streams to incorporate into our analyses and figure out how to use. Then we have, federal mandates for transparency and open data. It's also work. And we have flat budgets. So it's hard. So there's a lot of motivation for adopting these new efficient workflows because that frees up a lot of time and both time, but also mental energy for teams. So before I go into the training program, I need to give you a little background about why we organized this program the way we did. There's a lot of intentional thinking about how we structured this. And it's based on the nature of the nature of how ideas diffuse through a population. And an organization is a type of population. I'm going to summarize in just a few slides. It's very important work by E.M. Rogers about diffusion of innovation. And it's been shown that new ideas progress through a population in a very predictable stages and through very predictable personality types within a population. Each personality type or each group has different personalities, different motivations and objectives. So first are the innovators. Next up is the early adopters. And then we go into these majority groups. Let me briefly go through the three key groups, beginning groups. So first we have our early adopters. This group is really interesting. They get really excited by new ideas. And, the innovators here, they may come up with it, but the early adopter is the one who sees that idea and they are driven to create useful things. It's not just that they want to create new ideas. They want to take an idea and make it into something that people can use. They're simply driven to do this. They will pour themselves into this, hours upon hours into this, and they really can't stop this behavior. It's a core part of who they are. You will see these people in the early stages in the development of any new innovation. But they're not the majority of people. So let's now talk about the majority. So the first group is the early majority. And so the idea, once the early adopters kind of developed it into something that, was not very practical, they've now developed something practical. The first group that's going to take this up are the early majority. And they're not like early adopters, not going to get fixated on new ideas, but they're definitely open to new technology. They need convincing, but they're very open to it. They're going to listen. They're risk averse. They don't want to head down rabbit holes. They're price sensitive. And they're pragmatic, but they want to see new technology. Now, after them, the next big group are the late majority, and your leadership actually tends to be within this group. They're generally resistant to change. It's not that they're against new technology. That's not what it is. They're leading the ship. They're steering the ship. They need to be cautious, and they're definitely risk averse, price sensitive, and they're going to want to see some strong numbers to support adopting this, and they're going to want to see peers within the early majority who have vetted it and have shown that it's working. Okay, so when we think about the diffusion of new ideas, that early adopter group is really, really important. Their energy and effort is what drives the initial diffusion process. So it's critical that you reach these people. So we had these things very much in mind in the first 3 years of Openscapes. We knew we need to target the early adopters within NOAA Fisheries. We worked with Openscapes, who does specifically this kind of team training for environmental organizations, and they help environmental organizations with organizational change, cultural change towards open science. That's what they do. And, thinking about what I taught you about the early adopters, we recognize we need to target these people. So it's getting out the word and getting people who would opt in. And one interesting thing to note about these early adopters is they're often kind of sad and lonely. And the reason is they are rare, and they do just get fixated on new ideas, and they just pour themselves in. And they're surrounded by people who don't really quite get why they're so obsessed with these new ideas. And it's fascinating when you can get these early adopters together in a group, and then they just are working really hard to get together. Their energy level is going out the roof, and they can just accomplish things that they could never accomplish before. So this is what a NIMS Openscapes early adopter cohort looks like. The structure of this is these champions cohorts that meet. It's a cohort of 40 staff. And people come in typically with the team of people, a small team from work who have something that they want to work on. It's some work project that they are working on. And this small team, they opt in. They want to do this. They recognize their current workflow could improve, and they want to learn new ways to improve it. So it's not like they're learning skills that they might use in the future. They're learning things they're using right now, today, the next day, immediately. Every other week, they're learning with the facilitators with Openscapes. And it's honestly kind of less about any specific skills. It's not actually about coding so much. It's more about doing these things. So they're doing this kind of data journaling, journey mapping. So talking about all the work they're doing and mapping out where's the data coming in, where are the problems, and having very honest discussions within the team about where the problems are coming in. And so this facilitation that they're doing with Openscapes, a lot of it is psychological safety and team skills. How do you get teams to work better together? What are the kinds of conversations you have within teams so that you can have honest discussions about your workflow? Because people don't like to show that, the laundry's all over the floor and there's I mean that metaphorically, with their workflow or how they're doing something, they, it's got problems. They don't want to talk about it, but the team needs to talk about these things so that they can improve. We have done, over the last 3 years, we've done 9 of these cohorts, 40 staff each, and that's coming up on 400 staff. As I said, we work with Openscapes. They have worked, as you can see, I've got the logos up here, many, many different environmental organizations. I think importantly, notice they work here with NASA and EPA. They have a particularly big program with NASA, and it's very helpful for our NIMS Openscapes participants to be able to interact with their peers in other federal agencies, because talking with them, hey, how do you solve that? They really get, each side gets kind of new ideas, and the work just happens so much faster by being able to collaborate that way. All right, so I talked a little bit about that data journaling, our journey mapping that teams do. So here's an example. This is just from one team. So the before, they'll have a lot of red. Red is like bad flows where errors are coming in. They talk about why those are. Then they talk about where they'd like to go here in the bottom right. And then at this stage, the team gets depressed because where they want to go seems so hard to get to. How will they ever get there? And then we work at sort of bringing them out of that depression and starting to focus on small things they can do to move them forward. So they began slowly picking off tasks that move them in the direction they want to go. Okay, so what's next? Coming up on the end of my talk here. So next up, we're moving out of this early adopter group and starting to target the early majority. And at this point, this will now transition to being a NIMS Office of Science and Technology-led Open Science Initiative. And we'll be also changing it to something called the Openscapes Mentors Program. This is modeled off of what Openscapes has been doing with NASA. So let me talk a little bit about how that's different. So in the Openscapes Champions, we're working with individual teams, and that was honestly to help, first to help the teams, but also had the nice side effect of developing our mentor group, the people who really had a passion for this. And now in the Mentors program, it's really focused on supporting this mentor group as they come up with what they need at their local center, a science center, regional office, to help move their local community towards open science, better workflows. So there will be 2 to 3 mentors in each local center, and they will be working on ideas for helping their center. So now it becomes really a mentor-led program supported by Openscapes. And we have a nice sort of plan set out for what we're going to be accomplishing, really start kicking things off in start of fiscal year 2023. Okay, last couple slides. Just want to close off, say a little bit about NIMS Open Science. I've talked a lot about NIMS Openscapes. That's the training part. But we also have this NIMS Open Science. And the Open Science is a group of multiple Open Science affiliated and Open Science adjacent groups who work together collaboratively to support all the various needs of open science, open data, and fulfilling our various open science mandates, open NOAA data strategy, open source policy, federal data, et cetera, et cetera. We have a lot of these mandates. So we support staff in a lot of different ways. And here are some of the key things we've been working on. First off, we have 2 big groups that support development of research software, package development, models. Then we do a lot of support for our soft infrastructure and our development platforms. We have a POSIT Connect server. And then we have, we support our GitHub community in a variety of ways. And then we also support governance groups. For example, our GitHub governance groups. And then we have a very active R user group. Okay, and that is it. Thank you so much for having me today, and I look forward to your questions.